Hello, Dr. Webster. This is student 99S350070 with their test corrections. So our first question was about Dr. Franklin's uniform oil layer. So our goal was to determine the thickness of the oil layer. Since we already have our conversion factor of 1 centimeter cubed equals 0.0001 meters squared, then we just take our original centimeters cubed, we multiply that by our conversion factor, and we divide over our total meterage, which is 4,047 meters squared, which gives us an answer of 7.15 times 10 to the negative 4 centimeters cubed. For our next question, we were given 2 new bulbs and they lit longer than the old bulbs. So was it higher or lower resistance that caused this? So our goal was to explain why it was a higher resistance. So I said that the bulbs must have a higher resistance because in order for the bulbs to light longer, the energy must flow through the circuit at a smaller rate, and a higher resistance causes a smaller flow rate. So then for our circuit shown below, we had a compass under point A, and that was a little deflection because our circuit is 2 bulbs in parallel with 1 cell, so the bulbs aren't really going to be that bright. However, the flow rate should be still a common 3-arrow tail flow rate, and the compass deflection should be relatively low because they are in parallel, so the resistance isn't affecting each other. And then we added a third bulb to the parallel circuit right here, and because everything stayed the same except the addition of the bulb, we should still have the same flow rate and we should still have the same brightness. But when we put these two in a series, the flow rate should go down and the brightness should go down because the two bulbs are affecting the resistance of each other. And then we had to draw the diagram of a structure of a capacitor and describe it in words. So here we have the body of the capacitor and we have the 2 screws, and it says a capacitor is a device that can store energy. It is unique because it has 2 conductors separated by an insulator but still holds energy by becoming polarized. So how are a Genicon and a battery similar when they are connected in a circuit? How are they different? So our goal was to define a Genicon and a battery and then contrast them. So both a Genicon and a battery are sources of energy, but a Genicon can manually generate energy and cannot store energy like a battery. So a battery can hold energy and does not need manual labor, and a Genicon does. Okay, so for number 6, we had this circuit right here, and we have to determine which bulbs were lit and which bulbs were unlit. So, flowing from the positive to negative end of the battery, the only light A will light because it is the only one with both a side and a bottom attachment. And the flow rate should be normal because there isn't necessarily a whole lot of resistors in this series. There's only one. And B will not light. And then for our last question, we were asked about circuit location and origin of charge. So in previous classes, we know that the origin of charge, there isn't really one because charge originates everywhere. So our goal was to determine the origin of charge, and it originates everywhere. And then for our next ones, we had what direction would the compass needle deflect when the capacitor was charging? Because our diagram is of discharging, then it would be the opposite because we had a clockwise, so it's going to be counterclockwise now because we are charging as opposed to discharging. And in the reverse circuit, which way does the compass deflect? Well, if the circuit was reversed while it was charging, it would deflect clockwise. And if the capacitor was flipped for discharge, it would have been counterclockwise.